Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we will differentiate polynomials using the chain rule. So you might be thinking, well, hey, I already know how to differentiate polynomials. But what if we want to differentiate something like this? See, we're used to differentiating polynomials where it's, one term plus another term plus another term, and then we differentiate term by term. That's how we're used to doing this. But this is not in that form. And to get it in that form will be a lot of work. Because this is the power to 10, to expand these brackets would take forever. Even if we did that, there'd be 11 terms, and it would still take a long time to differentiate term by term. There has to be an easier way. And absolutely there is. It's called the chain rule. This in red is the chain rule. So remember, dy dx is the derivative of y with respect to x. And here we've got dy du, derivative of y with respect to u, times du dx. So if you like, we can sort of cancel out the two du's here. Now, I know you're probably thinking, well, hang on a minute, what is u? So it turns out the chain rule is also called the function of a function rule. This name's important because it tells us when we use the chain rule. We use the chain rule when we have a function of a function, then we let u be the first function and we put it into this formula. So this is an example where we have a function, x squared plus 5 is a function, raising to the power of 10 is a function. We have a function of a function. So this is like our first function, and it has something else to be done to it. So we're going to let u be the first function, x squared plus 5. So if u is x squared plus 5, we can rewrite y as u to the power of 10, x squared plus 5 to the power of 10. So to use the formula, we need dy du and du dx. So du dx is just u differentiated with respect to x. So that would just be differentiating like we normally do. We move the power to the front, decrease the power by 1. And remember, when you differentiate, constants vanish. So the derivative of this with respect to x is just 2x. So now we need to find dy du. So we need to differentiate y with respect to u. Well, that's easy as well. We just do what we've always done. So what we do is we move the power to the front, decrease the power by 1. So now we use the chain rule. So dy dx, which is the derivative of the thing in blue, is equal to dy du. So this is dy du multiplied by du dx. But of course, u is just x squared plus 5. So I'm going to take this u and replace it with x squared plus 5. So the derivative is 10u to the power of 9 times du dx there. And of course, we can make this a little easier to work with. 10 times 2x is just 20x. Okay, so you're probably thinking, well, that took a long time. Surely there must be a quicker way. And in fact, there is. See, what we've done to this one here, we still moved the power to the front and decreased it by 1. So that's how we got the 10. We took our function, moved the power to the front, we got 10, and decreased the power by 1. But what we also did was times by the derivative of what's inside the brackets. And that's the quick way to do it. Move the power to the front, decrease power by 1, but the chain rule says you must then multiply by the derivative of what's inside. So let's look at that quick way with a few examples. So let's have a go at differentiating these two. So we'll start with this one, another polynomial. Again, we don't want to expand the brackets. That would take forever. So we could write out u equals 3x minus 5 and then go through that process. But now we know the quicker way. Let's just use that. So we're going to move the power to the front. And then we're going to keep the thing in brackets. We're going to decrease the power by 1. And then we need to multiply by the derivative of what's inside the brackets. So the derivative of 3x minus 5 is just 3. So this will be the derivative. And of course, we write it simpler. 7 times 3 is just 21. So this way is much quicker than what I showed you on the previous slide. That was just so you understand it. Now, if you're not understanding this quick way, you can use the long way that I showed on the previous slide. That's fine too. All right, let's look at this function here. Well, it's actually not a polynomial, but we can still differentiate it in the same way. You see, this is just the same as x cubed minus 4. Remember, square root is to the power of a half, and because it was on the bottom of a fraction, it's negative. These two are the same thing. It's just this is now written in the form of the last two examples I've done, so we'll be able to do it easy. So to differentiate it, we're going to do the same as in the previous examples. We're going to move the power to the front, keep the thing in brackets the same. We're going to decrease the power by 1, and then we need to times by the derivative of what's in the brackets. The derivative of x cubed minus 4 is just 3x squared. So remember, when you're differentiating a constant like minus 4, the constant vanishes. So just making this a little easier to work with, minus a half times 3x squared, you can just write that as minus 3x squared on 2. And then this to the power of negative 3 over 2. It doesn't matter too much how you write it, but because it's minus 3 over 2, it would be written like this. X cubed minus 4 cubed. Okay? So there we have it. Much easier way to implement the chain rule. Thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.